Welcome back everyone. Today I am going to talk about ionic bond, which is bonding by electron transfer. The word ionic bond suggests that it is the bonding between ions. So before starting this session, let me ask this question. Why and how are ions formed? Let us find out the answer for this question by taking a familiar compound, sodium chloride. In sodium chloride, we have two different elements, sodium and chlorine. Now let us have a look at the electronic configuration of neutral sodium and chlorine atoms. Here we have sodium atom with 11 protons and 11 electrons, and with electronic configuration 281, 2 electrons in the first energy level, 8 electrons in the second energy level, and 1 electron in the third energy level, which is the valence shell. And we have the chlorine atom with 17 electrons and 17 protons, and with electronic configuration 287, again 2 electrons in the first energy level, 8 electrons in the second energy level, and 7 electrons in the third energy level, which is the valence shell. Now, according to octet rule, every atom try to attain stability by achieving octet in their valence shell. That we have already learned in the previous videos. So here, the sodium and chlorine atoms also try to attain stability. Then how can they do so? Look at the electronic configuration of sodium and chlorine. Here sodium has 1 electron in its valence shell. So if it removes this electron, the second energy level will be the valence shell, where it has 8 electrons, the complete octet configuration. And here chlorine has 7 electrons in its valence shell, 1 electron less for octet. So if it gets one more electron, it will have 8 electrons in its valence shell, which is the complete octet electronic configuration. So sodium is ready to remove electron and chlorine is ready to accept electron. So what happens when sodium and chlorine combine together? When sodium and chlorine combine together, sodium completely transfers its valence electron to chlorine. After this electron transfer, what happens to this sodium and chlorine atoms? Let us see. So after the electron transfer, now sodium has 10 electrons and 11 protons. So it becomes a positively charged ion, that is Na plus ion with electronic configuration 2,8, a stable electronic configuration. And chlorine has now 18 electrons and 17 protons. So it becomes a negatively charged ion, that is Cl minus ion with electronic configuration 288, the stable electronic configuration. So in sodium chloride, we have a positively charged ion, that is Na plus ion, and a negatively charged ion, that is Cl minus ion. So definitely there will be an electrostatic force of attraction between these oppositely charged ions. And this electrostatic force of attraction is the force that binds these ions together as a molecule. So we can call this force as ionic bond. So it is clear that ionic bond is the electrostatic force of attraction between oppositely charged ions. And what about the overall charge of this compound? Here we have one positive charge and one negative charge. So the overall charge of this compound is 0, or we can say that it is electrically neutral. So in general, the ionic compounds are neutral. Let us check this by taking another ionic compound, that is magnesium chloride. Magnesium chloride is formed from Mg2 plus ion and two chloride ions, that is Cl minus ion with one negative charge. So when this Mg2 plus ion and these two chloride ions combine together, ionic bonds are formed to form magnesium chloride. So in magnesium chloride, we have two positive charge and two negative charge. These two negative charge comes from this two chloride ions. So the overall charge of this compound is 0. So we can say that this ionic compound is also electrically neutral. Now, what is the condition for the formation of ionic bond? Here three ionic compounds are given: sodium chloride, magnesium oxide and calcium fluoride. Here sodium, magnesium and calcium are metals, and chlorine, oxygen and fluorine are non-metals. Metals are electropositive elements which are ready to remove electrons, and non-metals are electronegative elements which are ready to accept electrons. So in order to form ionic bond, one element should be an electropositive element, that is metal, and the other element should be an electronegative element or a non-metal. Okay. So this is clear from the periodic table that ionic compounds are formed from the metals from S block elements and these non-metals from P block elements, which are highlighted here. Now let us see what are the factors affecting the formation of ionic compound. Ionization energy, electron affinity and lattice energy are the three things that affect the formation of the ionic compound. Let us see one by one. What is meant by ionization energy and how it affects the formation of cation? Look at this equation. If we want to remove one electron from sodium atom to form Na plus ion or cation, we have to provide some amount of energy. So the energy required to remove an electron from an atom in the gaseous state is known as the ionization energy. So as the ionization energy decreases, the ease of formation of cation increases, which in turn favors the formation of ionic compound. Then what is meant by electron affinity? Electron affinity is the energy released when an electron is added to an atom and forms a negatively charged ion or anion. Here, when an electron is added to chlorine atom, it becomes chloride ion and some amount of energy is released, and this energy is called the electron affinity. So as the electron affinity value increases, the ease of formation of anion increases, which in turn favor the formation of ionic compound. Finally, what is meant by lattice energy? Look at the formation of sodium chloride. When sodium chloride is formed from Na plus and Cl minus ions, 786 kilojoule per mole of energy is released. So the energy released when 1 mole of an ionic compound is formed from its gaseous ions is called lattice energy. So the high amount of lattice energy indicates the formation of ionic compound. So in general, we can say that low ionization energy, high electron affinity, and high lattice energy favor the formation of ionic compound.